So with this one, writing the equation, we need two things. We need the point and the slope in order to write our equation. So the point, we have the x value of the point. To find the y, all we have to do is substitute that into our equation. So square root of 4 gives us 2 for our y value. Now to find the slope, we need to figure out the derivative of f of x. So to find the derivative, we should think of square root of x as x to the 1/2. And we use the power rule there. We take the 1/2 out in front times x to the negative 1/2. And that's our derivative. We want to figure out, though, what's the derivative when x is 4, because that's going to give us the slope of the tangent line. So we end up with 1 over 2 times square root of x. So in this case, square root of 4, because that x to the negative 1/2 can be written as square root of x in the denominator. And we end up with 1 over 2 times 2, or 1/4. So our equation for this one would be y minus 2 equals 1/4 times x minus 4. So there's our tangent line to that function at that point. Now down below we're going to look at this tangent line and the original graph. So it asks us to graph this with our calculator. We can do this without our calculator. What does the square root of x look like? The graph of square root of x. Half of a sideways parabola, right? So if we put 0 into that equation, we get 0 out, right? Square root of 0 is 0. If we put 1 in, we get 1. We're not going to put 2 in because square root of 2 is not going to come out nice, but we can put 4 in and we get 2 out. Square root of 4, that's the point of tangency that we're using. And then 9, square root of 9 is 3. So we have these 4 points we can use to graph our picture. Then we want to go ahead and graph our tangent line as well. So if we look at our tangent line, remember our point of tangency was at 4, 2. So it's going to be tangent right there. Then we're going to go ahead and use a slope of 1/4. So we're going to go up 1 over 4, go down 1 over 4 this way, and look at our tangent line. It's not looking too tangent, but pretend like it is. All right, so that should be tangent right here at 4, 2. And if my drawing skills were a little bit more accurate, you'd see this is pretty close right in this region, right by that point of tangency. Well, that's what this whole linear approximation is. We can use this line to approximate values that are really close to that point. So we're going to look at some examples here. It asks us to figure out what f of 3 is, and then figure out what is it when we put 3 into the equation of the tangent line. So f of 3, well, that's just going to be square root of 3, right? Because it was square root of x. So square root of 3, if we put it in our calculator, we'll round it to 3 decimal places. We get 1.732 approximately. Then it asks us, what happens if we put 3 into the equation of that tangent line? Well, we'd have y minus 2 equals 1/4 times 3 minus 4. So just putting in the equation we came up with. 3 minus 4 is negative 1 times 1/4, so we have y minus 2 equals negative 1/4. If we add 2 to both sides, we get 1.75. Okay, look at that. That's 18 thousandths off from the actual answer, approximately. Right? That's relatively close. Without actually using a calculator to figure out the square root of 3, we can get a pretty good approximation. And what you'll see is the closer we get to that point of tangency, the closer our approximation is going to be. Next, it asks us to try the same thing with 3.9. So let's try f of 3.9. That would just be square root of 3.9. And if we punch that into a calculator, we get 1.975 if we round to 3 decimal places. Well, let's see what we get when we put 3.9 into that tangent line. Y minus 2 equals 1/4 times 3.9 minus 4. So if we subtract here, we get negative 0.1, which is the same as negative 1/10. So we have 1/4 times negative 1/10, which is negative 1/40. Add 2 to both sides. Well, 2 is like 80/40, plus negative 1/40, we get 79/40. So this would be our approximation using the line. Well, let's see. Actually, we don't need approximately equals 2 signs, but let's take those equal. Let's see what we get if we do 79 divided by 40. 1.975, which is exactly what we had as a rounded to 3 decimal places. If you really want to impress your family at Thanksgiving, tell them you can figure out square root of 3.9 without a calculator to 3 decimal places and just blow them up. Joke. What's that? All right. So this is kind of a useful tool. If you couldn't use a calculator to figure out more complicated functions, you can actually use calculus to get really good approximations. So we're talking about linear approximation here. This is the formula. And it may look kind of complicated or different, but it's really something you know and you've known for years. Just a little different notation and written with slightly different modification, like slightly changed. So let's look at what this really is. This equation here is actually point-slope form, just kind of tweaked a little bit. So think about point-slope form. We have y minus y1 equals m times x minus x1. Well, if I take that point-slope form and add the y1 to the other side, we basically have this formula over here. Y f of x, y sub 1 f of a. That's what we get right here. If we put a in, something in for x, that's what we get out. So that's our y value. Plus m, our slope, well, here derivative. Derivative is slope, times x minus x sub 1. So x times x minus this x value. So really this is like point slope form, only adding that y over to the other side. Right, so it's just like point slope with the y added to the other side.